In section 1.3, we're talking about fractions and mixed numbers. Okay, we're going to start out very simple. These are things that you guys already know from the past. You maybe have used a calculator though for the last 5 or so years, so that you may be a little hazy on the details. However, what I see a lot of people thinking, and again, this is math teachers as well. If you have something like this, a lot of people think, well, why even bother? A calculator can do that for you. Absolutely, it can. However, what happens if that calculator breaks? Number one, that's still my first argument right there. But second argument is what happens when you have something like this. Calculator's not doing that for you anymore. Okay, but if we know the basics on how to do this, then it's the same mechanics on how to work that. Okay, so yes, calculators can do things for you, but there's a lot that they can't. Okay, so we want to make sure that we have these basics down, and I want you guys to always, if you can, put the calculator aside. I'm not saying to do that on a test. You don't practice your arithmetic when you're doing your taxes, okay? But when you're practicing, when you're doing your assignments, try to use the calculator as little as possible so you become a little bit more familiar and comfortable with the basic steps that are needed to carry out these problems on your own. Okay, it's going to be a lot more efficient, a lot more accurate. Again, if we go back to that car example, I don't want you to have to think, okay, where's my turn signal? That's a dangerous situation. If you're driving on the highway and you have to look down to see where your turn signal is, okay, it's going to be a lot safer, a lot more efficient if you can do things automatically. Stuff like this should become automatic. And that's going to take time and practice, but you'll get there. Okay, so drill this as much as you can. This is what we're going to talk about right now. So before we get into adding though, let's talk about just a basic fraction. Now, basic fraction is going to look something like that. Okay, A over B. Now remember, A is called the numerator, or the top is called the numerator, and the bottom is going to be called the denominator. Okay, so numerator on top, denominator on the bottom. We want to be able to get that language down so when I say it or you read it, you know what they're talking about. Okay, so numerator's top, denominator's bottom. The very first thing that we do with fractions is simplify them. Okay, so let's start with that. Let's start with 63 over 72. Okay, now when we simplify, there's a lot of ways to spell that out with factorizations and all that stuff. And that's the core of what we're doing. But in a more practical sense, what we're trying to do is, when we simplify, is find a number that divides both the top and the bottom of the fraction. Okay, so for instance, 63 and 72. I'm going to start out with a 3. Now, how do I know that 3 divides both of those? I could pick up a calculator, yeah. But let's say I don't have that. Take a 6 plus 3. 6 plus 3 is 9. 3 goes into 9, so 3 goes into 63. Okay? 72, that's also a 9. But those digits add up to something divisible by 3. The number is divisible by 3. Okay, that's a very nice, quick way of seeing if 3 goes into it or not. So I'm going to divide top and bottom by 3. 63 divided by 3 is 21. 72 divided by 3 is going to be a, what is that? Drawing a blank. 24. Ugh, okay, 24. And guys, if you get stuck, if you can do it in your head, great. If not, don't be afraid to do this. Do the long division. Again, the more of that you do, the better you're going to get at it, and you're going to be able to do that in your head a little bit more. People who do things in their head aren't just automatic. They just do things automatically. It's just natural. They've done this enough that they can picture it. Okay? So don't be afraid to write things out. Now, you got 21 over 24. That's not done. Okay? I can still divide by 3. 21 divided by 3 is a 7. 24 divided by 3 is an 8. And now that is a simplified fraction. Okay? Now, I see a divide by 3, divide by 3. What you could have also done, and if you do it this way, that's perfectly fine. You could have divided both of these by 9 right away and in one step simplified it down. That is the best way of doing it, but if you don't see 9, don't sit there forever trying to think of a bigger number. Just start taking those smaller numbers out. Okay? Next one, how about 64 over 12? Okay? Now, if you don't see anything else, these are even numbers. 2 goes into both of those. Okay? However, if you see that a 4 goes into both of those, that's even better. Okay? Because 64 divided by 4 is a 16. 12 divided by 4 is a 3. And that's it. Nothing goes into both 16 and 3. We're done in one step. If you are not comfortable doing that though, that's okay. Take a 2 out of top and bottom, take another 2 out of top and bottom. It'll give you the same result with one extra step. Okay? And if that one extra step is going to cost you 3 seconds, it's worth it. Okay? If it's an extra step that's going to cost you another 15 minutes, then maybe try and shorten the procedure. But if it's a few seconds here and there, take the safer path. Okay? So just be careful with that. And we got a simplified fraction. Okay? That is simplifying in a nutshell. So again, try these out. If you have a question, ask me, but also be patient. Okay? Take your time with it. Don't be afraid to start with these small numbers. You don't have to jump to a 9 or a 4 in this case. Next thing I want to talk about is multiplying and dividing fractions. Okay? First one, let's look at a multiplication problem. Okay, now, if we were to multiply fractions, what we do basically is multiply across top, multiply across the bottom. So many people are afraid of fractions because, oh, I got 3/16 and an 8/15. What the heck is that? Don't think of it as that. If we're multiplying, I'm not multiplying 3/16. I'm multiplying a 3 times an 8. No big deal. I'm multiplying a 16 times a 15. No big deal. That's it. Okay? Now here's the problem with doing it that way though. Notice this number gets kind of big. Okay? These are pretty nice when they come out, but sometimes these are just big numbers and they're nasty numbers that we still have to simplify. Okay? So what we can do with multiplication is actually simplify, then multiply. Only with multiplication we can simplify, then multiply. I'm going to say that again. Only with multiplication can we simplify, then multiply. Okay? So I'm going to take a 3/16 times 8/15. Now when I say simplify, I'm not talking simplify this. I'm talking anything on the top can simplify with anything on the bottom. That's a very powerful thing. Because instead of dealing with a 24 and a 240, 3 divides 3 once, 3 divides 15 5 times. Look at how much smaller those numbers are. Keep going. 8 divided by 8 is 1. 16 divided by 8 is 2. And now I'm not even multiplying as big a numbers, let alone simplifying them at the end. 1 times 1 is 1. 2 times 5 is 10. And I'm done. I would get the same thing if I did it up here. These are both divisible by 24, and I get the 1/10, but I have to go through that simplifying procedure on much bigger numbers. And I got to multiply bigger numbers. Some of you may be looking at 16 times 15 and go, oh, that's a pain in the butt. Then don't deal with it there. Deal with it here. Okay? And everything is a lot smaller and a lot easier to work with. Only with multiplication. Simplify, then multiply. Okay? Let's do one more. How about okay, now we're multiplying, so let's try, can we simplify anything on top with anything on the bottom? 2 and 7 don't have something in common to divide. 2 and 3 don't either. 8 and 7 don't. 8 and 3 don't. Okay, so we couldn't simplify. No big deal. But now we multiply. 2 times 8 is 16. 7 times 3 is 21. Now here's the beautiful thing. Don't look at this and say, oh, now I got to try and simplify that. Always simplify your fractions. Okay, but if you're looking at that, if you're trying to rack your brain on something that goes into both, if you couldn't simplify here, you wouldn't be able to simplify there. So as long as you do a good enough job simplifying here, don't even think about it at the end. Okay, again, those are only tips and tricks with multiplication. Okay, let's go on to division. So division, we've got, let's start with this. Let's say that. Now, guys, anytime in these videos, if you want to try that before I start talking about it, pause the video and try that yourself, and then see my explanation of it. Okay, there's nothing wrong with that. That's a good thing that you should be doing. Now, when we divide here, a lot of people want to jump and say, oh, those 4s can reduce. Again, you can only do the reducing first in multiplication. It's not multiplication yet. Okay? Now, notice I said yet, because when we divide fractions, all we do is keep this fraction along, as is, and I multiply by the reciprocal. That's it. Okay? Now, here's the thing. Once I make that, then the multiplication rules kick in. But notice that nothing's going to reduce. So I just go 3 times 5 is 15. 4 times 4 is 16. And there you go. Okay, make sure you do that change. So guys, really, division isn't its own thing. Division is simply a multiplication problem in disguise. Okay, you multiply by what we call the reciprocal, and we move on. Okay, let's do one more. Let's say that. Again, don't think about reducing anything. First things first. Division changes to multiply by the reciprocal. Okay? Now, can something reduce? Oh yeah. 7 divided by 7 is 1. 7 divided by 7 is 1. 6 and 15 also reduce. They're both divisible by 3. 6 divided by 3 is 2. 15 divided by 3 is 5. And now, very simply, 1 times 5 is 5. 2 times 1 is 2. End of story. That's much better than doing 7 times 15, then 6 times 7, and then reducing. Okay, so always, if you can, reduce first. Okay, that is multiplying, that is dividing. Again, if you have any questions, reach out, let me know. Let's move on then to adding and subtracting. Now, multiplying and dividing are linked, but they are separate ideas. Adding and subtracting are the exact same thing. So we're going to think of this as just one big idea. Okay, so let's start out with this. Okay, now if this is, again, this is old and you haven't thought about this in a while, remember when we add and subtract, you must have a common denominator first. Again, when you add and subtract, you must have a common denominator first. Okay, in this case, we have a common denominator. Think of these denominators as telling you the size of the piece that you're working with. So I've got 3 pieces of this size and 2 pieces of this size. Together, all I do is add across the top. I got 5 pieces of that size. End of story. There's nothing more to it than that. Okay, so again, yeah, 3 7s plus 2 7s. I hate fractions. If you know what to look at, it's not 3 7s plus 2 7s, it's 3 plus 2. And then you just carry that sevenths across. Okay, so once you know how to look at certain parts, fractions are a lot easier. I love working with fractions because the numbers are so much simpler than dealing with decimals. Okay, so I got 5 7s here, and we move on. Now what happens when we don't start with a common denominator? Let's say we've got 2/5 plus 1/4. Okay, now those denominators don't match. That's a problem we need to fix. So we need to make these match. Now when we look for a common denominator, what we're really looking for is a common multiple. Okay, multiples of 5, for instance, are 5, 10, 15, 20, 25, and so on. Multiples of 4, just start counting by 4. 4, 8, 12, 16, 20, 24, and so on. If that's not comfortable for you, write them out. There's nothing wrong with that. You've got 5, 10, 15, 4, 8, 12. Write them out until you hit a number that matches. Okay? In this case, that number is going to be a 20. Okay, so what I'm going to do is I'm going to change this into two equivalent fractions. Okay? So I want both of these to have a denominator of 20. Now how do I do that? I use multiplication, hence the multiple that we're looking for. Okay, so what do I multiply a 5 by to make it a 20? I multiply it by a 4. Okay, now remember that old rule. What you do to the bottom, you do to the top. Now I want to be very clear as to why that is. Okay, it's not just because that's what you do. Okay, a lot of you sometimes that's how you remember rules, because it was a rule. That's what we do. But I want you to start understanding why those rules are in place. Okay, practice the mechanics, but if you can grasp a certain amount of whys along the way, then it's going to make a lot more sense. But I don't want you to think I have to understand all the ins and outs before I can progress forward. That's not the case. Okay, so in this case, why are we doing 4 on top, 4 on the bottom? Because 4 and 4, 4 over 4 is a 1. If I multiply by a 1, I don't change anything. I don't change value. Okay, so that's why that rule is in place. 4 times 5 gives you that 20. 4 times 2 gives you that 8. 4 times 5 will give you 20. Do that to the top as well. 1 times 5 is a 5. And now 8 plus 5, they're both 20ths, is going to give you 13 over 20. Okay, take your time, be patient. Don't think that I have to do this in 10 seconds. Okay, if you can, great, more power to you. But if you can't, just keep practicing and it will get better. It will get faster. It will get, more importantly, more efficient. Okay, and you're going to be more accurate. Okay, that's the key. I would rather you guys take a little longer but get something right than rush through it and half of them are wrong. Okay, that's completely pointless, completely useless for everyone. Okay, so work on accuracy. Let's do one more. Let's look at that. Okay, now notice when we got a common denominator up here, we did 5 times 4. That we multiplied and we got a 20. That will work to get a common denominator, but sometimes the denominator is going to be a lot bigger than you need it to be. So like in this case, 6 times 12, that would be a much bigger number than we need. If we take a 6 and double it, we'll become a 12. So really the denominator we're looking for is just a 12. Okay? Now the reason why that happens here is there's common factors. Like a 3 goes into both of those. A 2 goes into both of them. A 6 goes into both of them. So it's not just multiplying and we get the best number. Okay? 5 and 4, there's nothing that goes into both of those. That's why we call them relatively prime, but that's why we could just multiply them together to get the 20. Over here, it's a better use of our time to just say 6 plus 6 is 12. Bingo, we got it. So the second fraction is good how it is. The first fraction, I need to multiply by 2, top and bottom. Again, why? Because that is a 1. 2 times 19, 38. Okay? Last thing, we then subtract across the top. 38 minus, or I'm sorry, 38 minus 23, and I keep the 12s. Okay? Now, why would I mark that wrong? Okay, I would mark it wrong because that's not reduced. With multiplying, we could reduce up front, multiply, and be done. But with addition and subtraction, I had to unreduce this to make it work. I had to cut it up into smaller pieces. Then I have to reduce at the end sometimes, so watch out for that. Both of these are divisible by 3. And we got that. Now guys, as we go further into this, I'm not going to require you to put divide by 3 the whole time. But right now, if you need it, put it down. Don't be so proud that I want to be able to do that in my head. You'll get there and you will be able to do it when the time is right. Okay, so don't hurt yourself, mentally because you're getting stuff wrong because you're not putting in those little details. Put the details in. It doesn't add a lot of time and it makes it a lot more effective, a lot more efficient. Okay, one last thing I want to talk about in this section. Let's talk about these mixed numbers. Okay, now mixed numbers are totally okay. There's nothing wrong with them per se, but we don't use them a lot in algebra. Okay, the reason why we don't use them a lot in algebra is because let's say we have a 3 1/3. That's a mixed number. Okay, that's understood to mean 3 plus 1/3. When we get into algebra and we deal with, like, let's say a 3x, that's understood to be 3 times x. That's a problem, okay? Because sometimes we think plus, sometimes we think multiply. That's why a lot of times in algebra, mixed numbers are not used. However, in this section, they do present them to you. So I want to show you how to handle them. Let's say we have a 3 1/3. Now, honestly, I don't work with mixed numbers. I just don't work with them. I get rid of them, okay? So to translate that into what we call an improper fraction, we take this and multiply with the number in the front. Denominator times number in front, that's a 9. And then I add that number on top. 9 plus 1 is 10, and I keep that 3 the way it is. That's it. And then I would work with it from there. So for instance, let's say I have a 2 1/8 times 1 1/3. Okay? I wouldn't work with them as mixed numbers. I would work with them as 8 times 2 is 16, plus 1 is 17. 3 times 1 is 3, plus 1 is 4/3. These are improper because the numerator is bigger than the denominator. That's what we would call an improper fraction. And then I'm back to the multiplication rules. Remember, simplify first. 4 and 8 are both divisible by 4. And now look how easy that is. I don't need to do 17 times 4. 17 times 1, piece of cake. 2 times 3, piece of cake. Okay? Now, typically I would just say leave that. However, when a problem starts with mixed numbers, typically they would want you to end with mixed numbers. So if they do ask you to do that, all you do is carry out division. 6 going into 17. 6 goes into 17 twice. 6 times 2 is a 12. And then I subtract. 17 minus 12 is 5, and there's nothing else to carry down. So what I would do is I would take that 5, which we call our remainder, and I put it over the divisor, this number out in front. Those are the same answer, okay? But please be aware, if they ask for mixed numbers, give it a mixed number, okay? Because a lot of times, like in cooking, for instance, you don't say 17/6 of a cup. You would say 2 5/6 cups. So there are applications for this, but when we get into the algebraic side of this course, which is going to be very soon here, typically we stick with this representation here. Okay, so that'll do it for section 3. Again, if you have any questions, let me know. Keep working hard, keep pushing forward.